Sketch below is the graph h of x. So we have h of x being equals to 1 divided by x plus p plus q. The asymptotes of h intersected a coordinate 1, 2, right? That's where we have our coordinate sim, right? Let's just call it a sim. And then 4.1.1 says that let's write down the values of p and q. The values of p and q. So q is the horizontal asymptote, right? So q is equals to 2. We can see it here from our graph, right? That's from our general knowledge of a hyperbola. So q is equals to 2. That's what we know, right? And then now we're looking for p, right? So if you look at this equation of the hyperbola here, we have x plus p, right? So to find p, you say x plus p is equals to 0, right? So x is equals to minus p. But then from our graph, we have the value of x. X is 1, right? So now you can see that minus p is just equals to 1. So if you solve for p here, you're gonna get p is equals to minus 1. So q is equals to 2 and p is equals to minus 1, right? Hence we have our asymptote at x is equals to 1, because if x is 1, then we have 1 divided by 0, which we're not supposed to have. Let's do 4.1.2. So 4.1.2 is saying that let's calculate the coordinates of the x-intercept of h. So as soon as I hear x-intercept, I'm letting y be equals to 0, right? So from h of x, I'm going to put 0, and then we have 1 divided by x minus 1 plus 2, right? So now if we take 2 to the other side, we're going to get minus 2 is equals to 1 divided by x minus 1. So minus 2x plus 2 is equals to 1. So minus 2x is going to be equals to 1 minus 2, that will be minus 1. So x is equals to 1 divided by 2. So our coordinate is 1 divided by 2 and 0. Let's do 4.1.3. 4.1.3 says that let's write down the x coordinate of the x-intercept of g. If g of x is equals to h and then x plus 3, right? So let's understand what g of x is doing to h of x. G of x is moving h of x 3 units to the left. If we have plus 3, we're moving 3 units to the left. If we have minus, we're moving 3 units to the right. It's counterintuitive, I know, but then it is what it is. So g of x, you just move h of x 3 units to the left, right? So if the x-intercept was at 1 divided by 2, now we have to move it 3 units to the left. How can we move it 3 units to the left? We're gonna say 1 divided by 2 minus 3, right? That's exactly what you're gonna say. And if we compute this, we're saying that x is equals to 1 divided by 2 minus 3, which will be equals to minus 2.5, right? So the new x coordinate of the x-intercept will be x is equals to minus 2.5, because we have moved h of x 3 units to the left. Now let's do 4.1.4. 4.1.4 says that the equation of an axis of symmetry of h is y is equals to x plus t. Determine the values of t. So we are given the slope, right? We just have to find t. So if you have an axis of symmetry, the point you substitute is this point here, where the axis of symmetry intersect. You substitute that point if you want, where the asymptotes intersect, I meant. That's the point you substitute if you want to find an equation of the axis of symmetry. So if we substitute that point, right, we're gonna get 2 being equals to 1 plus t, so 2 for the y and 1 for x. Yeah, so we're gonna get 1 is equals to t. So the axis of symmetry is 1 y is equals to x plus 1, and we just asked to find t, and then there we have t. So I think we're good to go. The last question, 4.1.5, says that let's determine the values of x for which minus 2 is less or equals to 1 divided by x minus 1. Let me show you something. If we take minus 2 to the right hand side, we're going to get 0 being less or equals to 1 divided by x minus 1 plus 2. And this is the equation we have in the graph, right? So what this question is asking us is to find the values of x for which the graph is at 0 or above, right? The values of x for which the graph is at 0 or above, right? So let's look for that. Let me just erase this so that we can have a bit of clarity. So let's go to our graph, right? We don't have to do this algebraically. Obviously you can, but then we don't have to if we have the graph already. So let's look at the graph. We can see here that for this part of the graph, this part here, the graph is greater than 0, right? So for all those values of x on that part, they satisfy what we're looking for. So we can say that when x is greater than 1, our equation is satisfied because h of x is clearly greater than 0, right? Now let's look at the other wing. We know that the x-intercept is here, right? And we've calculated it. That's when x is equals to 1 divided by 2, right? But if we go to the left, then our graph h of x is above 0, right? So on that side, we can say that when x is less or equals to a half, our equation is satisfied because h of x is either equals to right at x is equals to 1 divided by 2 or greater than when x is less than 1 divided by 2. Show that the turning point of f is at x is equals to 1 and y is equals to minus 4. Right, so we're given f of x being equals to x squared minus 2x minus 3. We want to show that the turning point of f is at x is equals to 1 and y is equals to minus 4. 4.1.1, back to the basics. We know that the x at the turning point is equals to minus b divided by 2a. And then a is this number we have there, right? So that is a, and then b is minus 2, and then c would be minus 3, right? So x will be equals to minus b is minus 2 divided by 2a. So we have 2 and then a is 1, and this will give you 1. So x at the turning point is equals to 1. Now to find the y value, we're going to say f of 1. We substitute in 1 into f of x. We're going to get 1 squared minus 2 multiplied by 1 minus 3. So 1 squared is 1, minus 2, that is minus 1, minus 3, we have minus 4. And as you can see, we have showed that the turning point is at x is equals to 1 and y is equals to minus 4. Let's move to the following equation. 4.1.2. Determine the coordinates of the x and y intercepts of the graph of f. Right, so x-intercept, let's start with the x-intercept. As soon as you hear x-intercept, you should be thinking y is equals to 0. Right, we have said that x squared minus 2x minus 3 is equals to f of x, right? That is our function. Now we'll let you know y be equals to 0 in order to find our x-intercept. So we're going to have x squared minus 2x minus 3 being equals to 0. We can simply factorize at this point. We can open 2 brackets is equals to 0. We have x there and we have x there. And then now the question I'm asking myself, which two numbers do I multiply and get minus 3? And when I add them, I get minus 2. That is minus 3 and plus 1. So x minus 3, x plus 1. So x is equals to 3 or x is equals to minus 1, x being equals to 3 and y being equals to 0. And then again here we have x being equals to minus 1 and y being equals to 0. So we have found the x-intercepts. We have found the x-intercepts. Let's go ahead and find the y-intercepts. So the y-intercept, so we're going to have x being equals to 0, right? So now we have f of x being equals to x squared minus 2x minus 3. We'll let in x be equals to 0 now. So we're going to have y being equals to 0 squared minus 2 multiplied by 0 minus 3. So y is equals to minus 3, right? So that is our y-intercept. Yeah, now we have all the intercepts that we were required to find. We can go ahead and do 4.1.3. So for 4.1.3, determine the points of intersection of the graphs of f and g. So the points of intersection, we simply let f of x be equals to g of x. F of x, we know fully well that is x squared minus 2x minus 3. It will be equals to x minus 5, which is our g of x, right? So we're going to take x to the left hand side and then take minus 5 to the left hand side also to get x squared minus 3x plus 2 is equals to 0. We can simply factorize this. So let's open our two brackets. Let's open our two brackets. Being equals to 0. So again, the key equation. Two numbers that when I multiply, I get 2. But when I add, I get minus 3. That is minus 2 and minus 1. So I'm going to have x minus 2, x minus 1. So x is equals to 2 or x is equals to 1 is where our graphs intersect. So we're supposed to find the points of intersection, not the x values of which they intersect. So we have to find the corresponding y value. So let's go ahead and do that. So when x is equals to 2, what is y equals to? It is equals to, if we use g of x, that will just be 2 minus 5, right? So y will be minus 3. And then when x is equals to 1, we have y being equals to 1 minus 5. So y is equals to minus 4, right? So this is the points of intersection. This is the points of intersection. Now in 4.1.4, we are required to sketch linked graphs of f and g on the same system of axes. Clearly label the turning point and where the graphs of f and g intersect each other, as well as the x and y intercepts of both graphs. So we have all the intercepts of f and we have the points at which they meet, right? Now we just need the intercepts of g of x, and then we're going to be able to sketch our graph. So let's go ahead and do that. So the x-intercept of g of x, we let in y be equals to 0, right? So we're going to have 0 being equals to x minus 5. So 5 is equals to x is one of the intercepts. So x, when it is 5, y is 0. So let's go ahead and find the y-intercept. So y-intercept, we let x be equals to 0. So we have y being equals to 0 minus 5. So y is equals to minus 5. So that is our y-intercept. When x is equals to 0, y is equals to minus 5. Yeah, I think now we have all we need. We can actually go ahead and sketch our function. So let's now I have my axis and I can then let's give it a try, right? So if we had asymptotes, we would start by sketching the asymptotes, but then in this case we don't have, so we're gonna start by the intercepts. Let's start with f of x. Let's start with f of x, and then we're gonna move to g of x. So f of x, we have two x-intercept. One is at -1 and the other one is at 3, right? So let's just indicate that we have one x-intercept here at -1 and we have another one at 3. So let's just leave that like that. Now let's move to the y-intercept. Our y-intercept, x is equals to 0 and y is equals to -3. So we have a point here. We have indicated the x-intercept. We have indicated the y-intercept. And lastly, we have a turning point at x is equals to 1 and y is equals to -4. So somewhere here we have a turning point. So now let's go ahead and sketch our graph. I think we have all that we need. So let's see what we're gonna have. So we're supposed to turn there at y is equals to -4 and then go up to x is equals to 3. So we need something like this, right? And then now g of x, we have an x-intercept when x is equals to 5. So right here we have an x-intercept, and then we have another coordinate, the y-intercept at y is equals to -5. So right here, right? And then our two graphs, they intersect once at the turning point of f, once here at the turning point of f, and again when x is equals to 2 and y is equals to -3. So somewhere here they intersect again. So let me try make that make sense. So we're supposed to have a line that will go through these 4 points. Some way, somehow, our line must go through those 4 points. So it should be something like that. This is what we're supposed to do for 4.1.4. It's not so neat like they've requested, but this is the best I can do. Right, let's move forward to 4.1.5. So 4.1.5, use the graph to determine the values of x for which f of x is greater than 0. Right, we can see here from -1 going to the negative, our f of x is greater than 0, right? And then from 3 going to the positive, f of x is greater than 0. So our answer, we have x being less or equals to -1, or x being greater or equals to 3. Write down the coordinates of the turning point of f. So f of x is equals to -x plus 3 to the power 2 plus 4, right? So the coordinates of the turning point of this function will be -3 and 4, right? We can clearly see that in our equation. But then for most people, it's a bit confusing when the equation is like this. They like to solve it first and then use x is equals to -b divided by 2a. So if we do that, we're going to have f of x being equals to -x squared plus 6x plus 9. That's what you get when you solve x plus 3 to the power 2 and then plus 4, right? So we're going to have -x squared minus 6x minus 9 plus 4. So this is equals to -x squared minus 6x minus 5, right? If you say x is equals to -b divided by 2a, you're going to get -6 divided by 2 minus 1, right? Which is equals to -3. And then if you substitute -3 into f of x, you're going to get 4. So indeed, the coordinates of our turning point, we have -3 and 4, right? But this is the equation of f of x, right? We're gonna need this equation as time goes, so let's just keep it there because we're gonna need it soon, right? And then 5.2, write down the range of f. So let's look at our function here. So we've already established that the y value here at the turning point is 4, right? And we can see that our graph never goes above 4. It just touches there at 4, and then it goes infinitely down, so to say, right? So we can say that y is less or equals to 4, right? For all the values of x, y is either 4 or less than that. All right, so that is the range of our function f. And then 5.3, this is where things start to get interesting. Show that the x coordinates of a and b are minus 5 and 2. So we say that f of x is equals to, so we have our function here, minus x squared minus 6x minus 5, right? So if we want to find the x coordinate of a and b, what we have to do is equate f of x, our parabola, right, and g of x, our straight line. So the equation of our straight line, we have g of x is equals to x plus 5. So if we equate those two, we're gonna get minus x squared minus 6x minus 5 is equals to x plus 5. Right, so we're gonna have minus x squared. We take in x to the left hand side, we're gonna get minus 5x, and then plus 5 is gonna be minus 5, right? So we have not minus 5 but minus 7, right? So we're gonna have minus 7x, and then minus 10 is equals to 0, right? Just one mistake and you're gone, right? So I have minus x squared here, which is, confusing me a bit. So I'm just going to multiply everything by minus 1, right? So that I can have x squared plus 7x plus 10 is equals to 0. Now it looks clean. I can go ahead and factorize. So I'm going to have that there. And then now the question I'm asking myself, which two numbers do I multiply and get 10? And then when I add, I get plus 7. That is 5 and 2. So I'm going to have x plus 5 and x plus 2. So it's easy to see now that x is equal to minus 5 or x is equal to minus 2. And then this is the x value of a and this is the x value of b. It's quite straightforward. There isn't really anything complicated in this one, right? Unlike 5.4 and 5.5. So let's look at 5.5. So 5.5 is saying that hence determine the values of c for which minus x plus c plus 3 squared plus 4 is equals to x plus c plus 5 has one negative and one positive root. At this point, our roots are at, let me just change the color real quick, at minus 5 and minus 2, right? That's where our roots are at the moment, based on 5.4. So now we need to shift our graph. Let's not forget that x plus something is shifting our graph, right? So let's shift our graph such that now one root is negative and then another root is positive, right? So if we have minus 2 here at b, we need to shift our graph just above 2 units to the right, just above 2 units to the right. Then one root is going to be slightly greater than 0 and the other one is still going to be less than 0, right? So that's what we want to do. So another thing to remember here is that if you have x plus 2, you are shifting your graph 2 units to the left, right? You're shifting your graph 2 units to the left. But then if you have x minus 2, you're shifting it 2 units to the right. I know it's counterintuitive that the plus is to the left and minus is to the right in this case, but that's what it is, right? So we need c to be just slightly greater than minus 2 so that we can shift our graph just more than 2 units to the right. So if c is just slightly greater than minus 2, then our problem is solved. We're going to have one negative and one positive root. Right, I'm interested in how you guys interpreted this question. Can you please just let me know in the comments if you don't mind? I would really appreciate that. Right, 5.6. 5.6 is saying that the maximum distance between f and g in the interval x of a and x of b. So yeah, in this interval, let me just erase this so that we can have a bit of clarity. Right, let me just put that there real quick. Right, so this is the interval we're interested in. This is the interval we are interested in. Right, so the question is saying the maximum distance between f and g in that interval is k, the maximum distance. If h of x is equals to g of x plus k, determine the equation of h in the form h is equals to. So we already have g of x, right? So to determine the equation of h of x, we just need the value of k. And then we are told that k is the maximum distance between f and g in that interval, right? So let's just go ahead and try find the maximum distance between f and g in that interval, right? So how do you find maximum distance? You say the graph on top minus the graph at the bottom is equals to 0, right? And then after that, you're gonna derivate the result and equate to 0. Let me show you what I'm talking about before I just confuse you. So we have f of x minus g of x, right? That is how you find the equation for the distance between the two graphs. So f of x minus g of x will be equals to what's our equation for f of x again? Where is it? Here it is. So we have minus x squared minus 6x minus 5, and then we're subtracting g of x, which is x plus 5, right? We're trying to find an equation for the distance between the two graphs, right? So we're gonna have minus x squared minus 7x minus 10. So this is the equation for the distance between the two graphs. So if we want to find the maximum distance, we have to derivate this equation and equate it to 0, right? So if we say distance, the derivative of the function for the distance is equals to 0, then we're gonna have minus 2x. We can just use the power rule, right? Minus 7 is equals to 0. So we're gonna have minus 2x being equals to 7, right? So x is clearly equals to minus 7 divided by 2. So let me just put minus 7 divided by 2 in the calculator. It's minus 3.5, right? And minus 3.5 is between minus 5 and minus 2. So right, that is the x value for which the distance between the two functions is at a maximum, right? Now we just need to find the distance by equating this answer into this equation, right? And then that will be the value of k, and we're gonna consequently have the function h of x. So if we sub x into that equation, we're gonna have minus 7 divided by 2 squared minus 7 divided by 2 minus 10, right? So that is our maximum distance. So let me just put that in my calculator and see what I'm getting. So minus 10, and I'm getting 2.25. I'm getting 2.25 units, right? So the value of k is 2.25 based on what I'm proposing here. So now we can go ahead and say that h of x is equals to g of x, which is x plus 5, and then plus k, which is 2.25, right? So we have x, and then what's 5 plus 2.25? That is plus 7.25. Write down the coordinates of E, the turning point of F. So we're given our equation f of x. Let's look at E. E is the turning point of our function. When our equation is written in this format, this will be the x value of the turning point, and this will be the y value of the turning point. That is to say that for the coordinates of E, we have x is equals to 7 divided by 2, and the y is equals to 81 divided by 4. If here we had a plus sign, then it would be minus 7 divided by 2. And then if we have a minus sign, it is just 7 divided by 2. That's how it works when you're given your equation in that form. Let's look at the equation that follows. 5.2. Determine the average gradient of the curve of f between x is equals to 1 and x is equals to 5. So we're looking for the average gradient. Let's just remind ourselves what gradient is. Gradient is just y2 minus y1 divided by x2 minus x1. In our situation, we are given x1 and x2. X is equals to 1 and x is equals to 5. So what we can do, we can find the y value when x is equals to 1 and the y value when x is equals to 5. How are we going to do that? It is easy. We just substitute in our function f of x. So we're going to say that our gradient is f of 5 minus f of 1 divided by 5 minus 1. y2 minus y1 is equals to x2 minus x1. So let's go ahead and substitute into our function f of x. So f of 5, we're going to have minus, and in place of x, we substitute 5. And then minus 7 divided by 2, everything to the power 2, plus 81 divided by 4. This is f of 5. We're supposed to subtract f of 1. We're going to have minus, in place of x, we have 1, minus 7 divided by 2, everything squared, plus 81 divided by 4. And then we're dividing everything by 5 minus 1. 5 minus 1 is 4. And if you put that in your calculator, you're going to get 1. So between x is equals to 1 and x is equals to 5, the average gradient is 1. That is how we can solve that problem. 5.3, calculate the value of a, the x coordinate of d. Let's go ahead and look at d. D is the point of intersection between f of x and g of x. So how can we possibly find d? We equate the two equations, and then the x values that we get are going to be for the points where those graphs touch. So what are we saying? We need to say that f of x is equals to g of x. The two functions, they touch at d and b. So we're going to get the x values of b and d after we solve for x. What is f of x? F of x is in this format. Let's write it in our standard format first. So f of x is equals to minus. What is x minus 7 divided by 2 squared? X multiplied by x is x squared. X multiplied by minus 7 divided by 2x is minus 7 divided by 2x. You multiply that by 2, you get minus 7x. And then on the other hand, minus 7 divided by 2 squared, that will be just 49 divided by 4, plus 81 divided by 4. If we multiply out, we're going to get minus x squared plus 7x plus 8. So this is our f of x. Now we can go ahead and
equate f of x and g of x. So minus x squared plus 7x plus 8 is equals to g of x. G of x is minus 3x plus 24. If we take minus 3x to the left hand side, we're going to get minus x squared plus 10x. 24 to the left hand side, we're going to get minus 16 being equals to 0. If we multiply out by minus 1, we're going to get x squared minus 10x plus 16 being equals to 0. Two numbers that we multiply and get 16, but when we add them, we get minus 10. That is minus 8 and minus 2. So we have x minus 8 multiplied by x minus 2 being equals to 0. X is equals to 8 or x is equals to 2. Let's see what makes sense. We are looking for the x coordinate of D. We have D and B. X of D will obviously be equals to 2. We cannot say that x of D is equals to 8 and x of B is equals to 2. It doesn't make any sense. It is easy to say that x of D must be equals to 2. That is 5.3. 5.4. Let's take a look at our equation. Point S of coordinates x and y is a point on the graph of f. We can clearly see it here on our graph, where x is between a and 8. Line ST is drawn parallel to the y-axis with point T on the graph of G. Determine ST in terms of x. ST, let's look at our graph. We're looking for ST. We solved a very similar question not long ago, but let's just go ahead and solve this one. In this interval where x is between a and 8, the graph of f of x is greater or equals to g of x. If we want to find the length of that distance st, it is just a matter of saying that the distance is equals to f of x minus g of x. So what is f of x again? Minus x squared plus 7x plus 8 minus g of x. G of x is minus 3x plus 24. So let's go ahead and solve this. Minus x squared and then plus 7x minus 3x, that will be plus 10x, and 8 minus 24, that is minus 16. So this is the equation of ST. We can do 5.4 now if we have the equation of ST. In 5.4, we're supposed to calculate the maximum length of ST. Well, ST is equals to minus x squared plus 10x minus 16. Let's derivate. So s prime of x, we're going to have minus 2x plus 10. We're supposed to equate this to 0. So we're going to have minus 2x plus 10 is equals to 0. Minus 2x is equals to minus 10. X is equals to 5. Now, if we substitute 5 into ST, we're going to have 5, we have minus here, squared plus 10 multiplied by 5 minus 16. This is equals to 9.
Now I'm under the impression that if the sketches look complicated, then the questions are actually easy. And then if the sketch look kind of plain, and then the questions might be hard. So let's see what's happening in this question here, right? So for 4.2.1, the question is saying that let's write down the y coordinate of C, right? So clearly we have two graphs here, f of x, which is x squared minus 4x minus 5, right? Which is the quadratic function you see on the graph. And then we have an exponential function, g of x, right? Which is a multiplied by 2 to the x plus q. And then e and h are the x-intercept. We have e here, as you can see, and then we have h here being the x-intercept. So this line here is actually our x-axis, and this line here is our y-axis, right? And then c is the y-intercept of f. So we have c here being the y-intercept of f, and it lies on the asymptote of g. Okay, c is the y-intercept and it lies on the asymptote of g. The two graphs intersect at d, so they're intersecting here at d, the turning point of f. So the first question, the y coordinate of c. So c is the y-intercept of f, right? So if we're looking for the y-intercept, we always let x be equals to 0, right? So for that function f of x, if we do that, we're gonna get f of 0 being equals to 0 squared minus 4 multiplied by 0 minus 5, right? So it should be easy to see here that f of 0 is gonna be equals to minus 5, right? So the coordinate, the y coordinate of c is clearly minus 5, right? Because that's what we get when we let x be equals to 0. And then the next question, 4.2.2, let's determine the coordinates of d. D is the turning point of f of x, right? So we have f of x, let's not forget, being equals to x squared minus 4x minus 5, right? If we want to find the coordinates of the turning point, it's beneficial if we start with the x value of the turning point, right? Because we have a formula for that. We can say that x will be equals to minus b divided by 2a. So this will be equals to, so b is the coefficient of x, right? So that's supposed to be minus 4. And then a is the coefficient of x squared. So we're just going to have 1 there. So now we can see that x at the turning point should be equals to 2, right? Now that we have that 2 there, we're just going to substitute it in the equation f of x, right? F of 2 being equals to 2 squared minus 4 multiplied by 2 minus 5, right? So this will be equals to, so we have 4 minus 8 minus 5, and that should be equals to minus 9, right? So the coordinates of d, we have 2 for the x value and minus 9 for the y value, right? It's easy to see. Now let's do 4.2.3. So 4.2.3, we're looking for the values of a and q, right, from our graph g of x. So g of x is equals to a multiplied by 2 to the x plus q, right? Q is the asymptote of our graph, but we are told that the asymptote of g is at the y-intercept of f. So now we can easily say that q is equals to minus 5. So if q is equals to minus 5, then we have g of x being equals to a multiplied by 2 to the x minus 5, right? So now what we can do here, we can substitute the coordinate d so that we can find a, right? D as coordinates 2 and minus 9, because d lies on f of x and g of x, so we can substitute it in that equation. So if we substitute it, we should get minus 9 is equals to a multiplied by 2 to the 2 minus 5, right? So minus 9 equals to 4a minus 5, right? So minus 4 is equals to 4a. So a is equals to minus 1, right? So we have determined the value of a, and we have determined the value of q, right? Let's do 4.2.4. So 4.2.4 is saying that let's write down the range of g, right? So we have g of x being equals to minus 2 to the x minus 5, and we're supposed to determine the range of the graph, right? We can just easily look at the sketch here, right? Because as you can see, the y values will never be greater than minus 5, right? They actually never touch there. The y value gets approximately, it gets infinitely closer to minus 5, but then it never really touches minus 5, right? But then going down the y value goes to minus infinity, basically, right? So we're saying that the y value will always be less than minus 5, right? The y value is always going to be less than minus 5. So 4.2.5, determine the values of k for which the value of what? F of x minus k will always be positive, right? If we come to our graph f of x here, our turning point is here at d, where the y value is minus 9, right? So we know if we have f of x plus 3, then that moves the entire graph 3 units up, and then if we have f of x minus 3, then that moves the entire graph 3 units down, right? Then we have to shift it more than 9 units up, right? If we want our graph to always be positive, because if we shift it more than 9 units up, then it's going to be above the axis, so all the values will be positive, right? But here, the tricky thing is here, we have f of x minus k, right? So if k here is less than minus 9, then we will have shifted our graph enough units such that the entire function f of x is positive. Let's go ahead and calculate the coordinates of d. D is right here. It's the turning point of our graph, right? We have f of x being equals to x squared minus 4x minus 11, right? And then we want the x value of the turning point first, and after we have the x value, we can find the y value, right? So this is how you find the x value. You say that x is equals to minus b divided by 2a. This will always hold when you want the x value of the turning point. But the question now is, what is b? B is the coefficient of x, and then what is a? A is the coefficient of x squared. So this will be equals to, so we have minus b, right, which happens to be minus 4, and then divided by 2, a happens to be 1. So this will just be equals to 4 divided by 2, which will just be equals to 2, right? So now that we have the x value, we can just substitute it in our equation and find the y value. If we do that, we're going to get f of 2 being equals to 2 squared minus 4 multiplied by 2 minus 11. So what is 2 squared? That is 4. And then minus 8 minus 11. So 4 minus 8, that is minus 4 minus 11, that should be minus 15. So the coordinates of d, we have an x value of 2 and a y value of minus 15. And just like that, you have the coordinates of d. So now let's go ahead and do 6.1.2. Let's calculate the distance cn. So here's c here at this point, and n is right here, right? But then we don't have the coordinates of c. If we had an equation for this graph g of x is the straight line, it will be easy to find the coordinates of c and then consequently find the distance cn. But we're told in a question statement that g of x is equals to the derivative of f of x, right? So we can just derive f of x and have g of x. If we do that, we're going to get g of x being equals to the derivative of f of x. So we're going to get 2x minus 4, right? And if you have no idea what is going on, then I advise you to just click on the channel and go watch a video on differentiation, right? But then that's not the only way you can solve that problem. You can actually find the y value of m. If you find the y value of m, then you're going to have m and n as 2 points on a line. And then from there, you can then find this equation here and do what we're about to do next, right? Yeah, so let's go ahead with the problem. We want the coordinates of c, right? So for c, we have an x coordinate that we don't know and a y coordinate of 0, right? So if we substitute 0 in place of y, we're going to be able to find the corresponding value of x. So let's just go ahead and do that. We're going to have 0. We're substituting it into g of x, right? That will be equals to 2 multiplied by x minus 4, right? It's easy to see that x should be equals to 2. So for c, we have coordinates 2 and 0, right? So we have the coordinates of c. We know that the coordinates of n is 7 and 10. So now we can go ahead and find the distance cn. So if we do that, we're going to have cn being equals to, now we're using the distance formula, right? y2 minus y1 squared plus x2 minus x1 squared, right? So this will be equals to, so let's take our point n as the second point. So we're gonna have 10 minus 0 squared, right, plus 7 minus 2 squared. So this will be equals to, so we're gonna have the square root of 110 squared, and then 5 squared, that will be like plus 25. And then if you put that in your calculator, you should get 5 square root of 5 square root of 5. Yeah, so the distance of what? The distance of Cn seems to be 5 square root of 5, right? And now we can move to the next question. Let's do 6.2 and then 6.2.1, for which values of x is f of x. So f of x less than g of x. F of x less than g of x. So we're looking for the x values where g of x is on top of f of x, right? We can see that here between the x value of m, between the x value of m and the x value of this point n here, our graph g of x is above f of x, right? So we can say that from minus 1 to just slightly less than 7, g of x is greater than f of x. You can see clearly here that our graph g of x is above f of x, right? Yeah, so that's what we're talking about there. And then 6.2.2 is saying let's find for which values of x is g of x minus f of x a maximum, right? G of x minus f of x a maximum, right? So let's substitute g of x first so that I can show you something. So g of x, we have 2x minus 4, and then minus f of x, which happens to be x squared minus 4x minus 11. So this should be equals to, yeah, it should be equals to, so x squared doesn't have any other like term, so we have minus x squared, and then 2x minus 4x, so that will be plus 6x, and then minus 4 minus 11, so that will be plus 7. So how we solve that problem now? When we have this equation, we derivate and equate to 0. That's when we're gonna have a maximum. So if we do that, we're gonna have minus 2x plus 6 being equals to 0. So it's easy to see that minus 2x will be equals to minus 6. So x is equals to 3. Show that the equation of g can be written as y is equals to 2 divided by x minus 1 plus 2. We have two functions, f of x, which is equals to x plus p squared plus q, and g of x, which is equals to a divided by x plus b plus c. And that function g of x is said to be y is equals to 2 divided by x minus 1 plus 2, and that is what we are supposed to show. Well, let's start here. G of x is equals to a divided by x plus b plus c. As you can see from the format of this function, it is a hyperbola, right? It has a vertical asymptote and a horizontal asymptote. It's those kind of things that we're going to use to answer this question, because we know that for a hyperbola, c is your horizontal asymptote, while x plus b is equals to 0 will give you your vertical asymptote. So let's go ahead and find or extract the value of c, because we are given the horizontal asymptote. So the horizontal asymptote is right here at x is equals to 2, right? So that is to say that the value of c on our function g of x is equals to 2. Now we just need to find b using the vertical asymptote. While under normal circumstances, if you're trying to find the vertical asymptote, you're going to say that x plus b is equals to 0, and then x will be equals to minus b. In this example, we have the x value at the vertical asymptote is right here. X is equals to 1, so we're gonna have 1 being equals to minus b. So if we solve for b, we're going to get b being equals to minus 1. So we have the value of c and we have the value of b. We just need to find a. How are we gonna possibly do that? In our question statement, we are told that the graph G passes through the origin. So on the graph G of x, on the function G of x, we have a point of coordinates 0 and 0. So if we substitute that, we're gonna then be able to find the value of a. So let's go ahead and do that. The y value at this point is equals to 0, and then we have a divided by x plus b. X at this point is also equals to 0, while b on the other hand is minus 1, and then plus c, which is plus 2. If we take 2 to the other side, we're going to get minus 2 being equals to a divided by minus 1. We know fully well that minus multiplied by minus is positive, so we just have a being equals to 2, which means that our function g of x is indeed equals to 2 divided by x minus 1 plus 2. We have the value of a, b, and c. Let's move to 4.2. So the question in 4.2 is saying that let's calculate the coordinates of p. What is p? P is right here. It is the turning point of f of x, but we're given the x value at p, because look at this vertical asymptote. It goes through p, so that tells us that the x at the turning point is equals to 1. Now we just need to find the y at the turning point. It's the only thing we're left with. Well, our function f of x is equals to x plus p squared plus q. So in this general format, q is your y at the turning point, while p is equals to minus x of the turning point. Let's go ahead and substitute that before you start feeling bamboozled. We're gonna have f of x being equals to x, and then we're saying that p is equals to minus x at the turning point. We said that x at the turning point is equals to 1, so we must substitute minus 1 here. Everything squared plus q, y at the turning point. So let's take a point on the graph. We can take a. A is a point on the graph f. If we substitute a, we're gonna have a y value and an x value. The only thing that we're gonna be left with is q. So let's go ahead and do that. The y value is 0 and the x value is 5 divided by 2 minus 1 squared plus q. 0 is going to be equals to 9 divided by 4 plus q. So q will be equals to minus 9 divided by 4. That is to say that the coordinates of p, the coordinates of the turning point, we have 1 and minus 9 divided by 4. Let's move to 4.3. 4.3, write down the equation of the vertical asymptote of p if p of x is equals to g of x minus 1. Let's see what g of x minus 1 is first before we can do anything else. So we know that g of x at this point is definitely equals to 2 divided by x minus 1 plus 2. So g of x minus 1 will be equals to 2. In place of x, we then substitute x minus 1. Right. So we're gonna have x minus 1 minus 1 plus 2. So g of x minus 1 is just equals to 2 divided by x minus 2 plus 2. In order to find the vertical asymptote, we have said before that we take the denominator and equate it to 0. So we're gonna have x minus 2 being equals to 0. So x is equals to 2 will be our vertical asymptote if p of x is equals to g of x minus 1. Why do we equate the denominator to 0? That is because we cannot divide by 0. We're gonna have undefined. So that's why we say it is our vertical asymptote. Let's carry on. 4.4. Determine the equation of the axis of symmetry of G in the form y is equals to mx plus c if m is less than 0. So we have Q equation of axis of symmetry, right? One equation is y is equals to x plus c, and the other one is y is equals to minus x plus c. Is it that your gradient is going to be positive 1 or minus 1? So here, if they're saying that m is less than 0, then we're supposed to use y is equals to minus x plus c. So we're going to have y being equals to minus x plus c. So we just need to find the value of c. We need to substitute a coordinate here. But which coordinate do we substitute? You substitute the vertical asymptote in place of x and the horizontal asymptote in place of y. So if we go ahead and do that, the horizontal asymptote is 2 and the vertical asymptote is 1 plus c. So 3 is equals to c and y will be equals to minus x plus 3. And just like that, we have our axis of symmetry when m is less than 0. Let's go ahead and do 4.5. Write down the equation of k if k is the reflection of G about the x-axis. If it is a reflection of G about the x-axis, then k will be equals to minus G of x. That's what a reflection about the x-axis will look like. So we have k being equals to minus. Now we just need to substitute g of x, which is 2 divided by x minus 1 plus 2. K will be equals to, so we have negative multiplied by positive, which will give us negative, right? So we're going to have negative 2 divided by x minus 1, and then negative multiplied by positive, it will give us negative again. So we just have minus 2. And just like that, we have k. K is equals to minus 2 divided by x minus 1 minus 2. The last question, 4.6, for which values of x is f of prime x multiplied by g of x greater than 0. We're looking for the values of x for which the gradient of f of x, f prime of x is the gradient. The gradient of f of x multiplied by g of x will be greater than 0. If you look at the graph and do some analysis, you're going to realize that that is true when x is greater than 0. Our only restriction being that x cannot be minus 1.
Most people don't know this, but we actually have an equation for the turning point of a quadratic function and the range. And I'm going to use those exact formulas to answer this question. Let's look at 7.1. The question is saying, let's write down the coordinates of B and D. B and D are the x-intercepts of our function. We are given the function f of x being equals to x plus 4 multiplied by x minus 6. Obviously, if we solve for x here, we're going to get x is equals to minus 4 or x is equals to 6. It will be easy to see that between minus 4 and 6, the x coordinate of B is minus 4 and the y coordinate is 0 because it is the x-intercept. And then this is the coordinates of B. The coordinates of D, we have 6 and 0. And just like that, we've answered 7.1. Let's look at 7.2. Calculate the coordinates of C. C is the turning point of f of x. We are given that f of x is equals to x plus 4 multiplied by x minus 6. Let's go ahead and multiply out. If we do that, we're going to get x squared minus 6x plus 4x minus 24. So we're going to have x squared minus 2x minus 24. If we want to find the x value of C, we say minus b divided by 2a. Where b is the coefficient of x, it happens to be minus 2. divided by 2a. A is the coefficient of x squared, which is 1. So 2 divided by 2, that is 1. Now we come to the y value of c. This is what I was referring to. We actually have a formula for that. We can substitute back into our equation, but we don't really have to do that. The formula, it is c minus b squared divided by 4a. So what is the value of c? The constant. That is minus 24. So we're going to have minus 24 minus b squared. B is minus 2. We square that and we divide by 4a. A is 1. So we're going to have minus 24 minus what is minus 2 squared. That is just 4. You divide that by 4, we just get minus 1. So minus 24 minus 1, that is minus 25. So the coordinates of C, we have 1 as the x value and minus 25 as the y value. Let's go ahead and do 7.3. 7.3, we're looking for the range of f. F is concave up. If f is concave up, then the range will be given by y is greater or equals to y at the turning point. But we know that y at the turning point is minus 25. So y is greater or equals to minus 25. Just like that, we've answered 7.3. 7.4. Let's look at what the question is saying. Given that theta is equals to 14.04 and the tangent to f at t is perpendicular to AE, 7.4.1, let's calculate the gradient of AE. If we're given the angle, then it will be very easy to compute. We know that tan of theta is equals to the gradient of that line. It happens to be AE in our case. So we're going to have tan of 14.04 being equals to the gradient of AE. If you put that in your calculator, you're going to get 1 divided by 4 being equals to the gradient of AE. Let's look at the equation that follows, 7.4.2. Let's calculate the coordinates of t. We are told that t lies on a tangent that is perpendicular to AE. So we can find the gradient at t with ease. Because if the tangent is perpendicular to AE, then the gradient of the tangent multiplied by the gradient of AE will give us minus 1. So the gradient of the tangent multiplied by AE, that is 1 divided by 4, is equals to minus 1. So the gradient of the tangent will be minus 1 divided by 4. If you solve that, you should get minus 4 as the gradient of our tangent. The tangent touches f of x at t. So we can derivate f of x and find f of prime x. And then that is how we're going to get to the x value of t. So if we do that, f of x at this point, we know it is equals to x squared minus 2x minus 24. If we derivate this, we're going to get f prime of x being equals to 2x minus 2. And that's it. We know that the gradient at that point is minus 4. So we can say that 2x minus 2 is equals to minus 4. What are we trying to do here? We're trying to find the value of x for which the gradient is minus 4. And we know that the gradient is minus 4 at t. That's why we are doing this. So we're going to have 2x being equals to minus 2 plus 2. That will be minus 2. So x is equals to minus 1. Now we can substitute this value into f of x. So f of minus 1 will be equals to minus 1 squared minus 2 multiplied by minus 1 minus 24. This will be 1 plus 2 minus 24. So we have minus 21. The coordinates of t, the x value is minus 1 and the y value is minus 21. The last question, 7.5. A straight line G parallel to AE cuts F at K and R. Calculate the x coordinate of R. Right, so what we are going to do here, we're going to find the equation of G. We are going to find G of x. And then after finding G of x, we can equate G of x and F of x. And then we're going to find the x coordinates of which they touch, which happens to be K and R. So our first step, let's find the equation of G of x. So we're given the gradient of G of x, so to say, it is said to be parallel to AE. The gradient of AE is 1 divided by 4, so the gradient of G of x should be 1 divided by 4. Now we just need to find C, but we're given K, a coordinate on G, so C should be quite easy to find. If we substitute K, we're going to get minus 9 being equals to 1 divided by 4 multiplied by minus 3 plus C. So minus 9 plus 1 divided by 4 multiplied by 3 is equals to C. So C is equals to minus 33 divided by 4. So G of x is equals to 1 divided by 4x minus 33 divided by 4. We need to equate this to f of x. We're going to be able to find the two x values for which f of x and g of x touches. That is how we're going to get the x coordinate of R. So let's go ahead and say that g of x is equals to f of x. So g of x is a half x minus 33 divided by 4. And then f of x, on the other hand, we have x squared minus 2x minus 24. So if we rearrange this, we're going to get x squared minus 2x minus 1 divided by 4x, and then minus 24 plus 33 divided by 4 being equals to 0. It will be wise for us to multiply out by 4 because we have 1 divided by 4 and 33 divided by 4. If we multiply it by 4, everything sits down. So let's go ahead and do that. We're going to have 4x squared minus 8x minus x, and then 24 multiplied by 4. So that is 24, 48, 96 plus 33 being equals to 0. So if we solve that, we're going to get 4x squared minus 9x minus 63 being equals to 0. So now it is just a matter of factorizing. You can use the quadratic formula because of this coefficient of 4. It becomes really hard to factorize using your mind without the aid of a calculator. So if we factorize anyway, we should get 4x minus 21 multiplied by x plus 3 being equals to 0. So x is equals to 21 divided by 4, or x is equals to minus 3. We know that x is equals to minus 3 is the x value of k. That just tells us that x is equals to 21 divided by 4 is the x value of R.
In order to sketch an exponential function, we don't really need much. We need the asymptote and the intercepts, right? So here we're given f of x is equals to minus 3 to the power x plus 1, right? But then the general formula of an exponential function is as follows. We have f of x being equals to a multiplied by b to the power x plus k, right? So k is always going to give us the asymptote, right? And then the value of a is going to determine whether our graph is below the asymptote or above the asymptote. So let me show you what I'm talking about. So if we have fx is equals to minus 3x plus 1, then y is equals to 1 is going to be our asymptote, right? So y is equals to 1 is going to be our asymptote. And then now we're just left with the intercept. So if we get the intercepts, we're going to be able to sketch our graph, right? So let's go ahead and say x-intercept. So we know that if we're looking for the x-intercept, we'll let y be equals to 0, right? So we're going to have 0 being equals to minus 3 to the power x plus 1. So let's take 1 to the left hand side. We're going to get minus 1 being equals to minus 3 to the power x. So 1 is equals to 3 to the power x, right? We can write 1 as 3 to the power 0, right? And then it will be equals to 3 to the power x. So if we drop the bases and equate the exponents, we're going to get x is equals to 0, right? So we have one intercept at x is equals to 0 and y is equals to 0. So from this point, I know that the y-intercept will also be equals to 0. But then let's just do it for the sake of clarity. So y-intercept will let x be equals to 0. If we do that, we're going to get y being equals to minus 3 to the power 0 plus 1. So y will be equals to minus 3 to the power 0 will be 1. And then plus 1, this should all be equals to 0. So y-intercept is also at 0 and 0, right? So now we have our intercepts and we have the asymptotes. So we can go ahead and sketch our graph, right? So let me just put the axis real quick and then we're going to be done in no time. So there we go. We have our axis and then we know that we have an intercept here at x is equals to 0 and y is equals to 0. And then let's go ahead and put our asymptote. Our asymptote is at y is equals to 1, right? So we have an asymptote there. So let's just go ahead and indicate it. So there goes our asymptote. Like I've already said, if from this general formula here, if a is less than 0, our graph will be below the asymptote. And if it is greater than 0, it will be above. So since here we have f of x is equals to minus 3 to the power x plus 1, our graph should be below that point. So here we're going to get something like this. We shall go through the intercepts, right? So there goes our graph f of x. So that's essentially how we answer those kind of problems. And now moving forward to 5.2. 5.2 is saying let's write down the range of f. We can see that f of x will never be greater than 1, right? So we're going to say that the range or the y values will always be less than 1, right? Yeah, because of the asymptote that is restricting us there. And then 5.3 says let's determine the equation of the asymptote of g, given that g of x is equals to minus f of x, right? So let's just go ahead and substitute f of x and see what we're gonna have. So we're gonna have minus and then f of x that is minus 3 to the x plus 1, and then if we multiply that out, we're gonna get 3 to the power x minus 1, right? So I've already said that this term here is our asymptote. So for 5.3, the asymptote of g will be y is equals to minus 1. And just a side note, because we have a plus here and not a minus, we would expect our graph to be above the asymptote, right? Let's move to 5.4. If g is shifted 1 unit upwards to give a new function h, determine the equation of h inverse. So let's just go ahead and see that h of x is equals to g of x plus 1, right? That's how we shift it upwards. If we were shifting it downwards, we would say minus 1. So h of x is equals to 3 to the power x minus 1. Let's not forget the equation of g of x is right here. And then everything plus 1. So h of x will just be equals to 3 to the power x, because minus 1 plus 1 will just be equals to 0, right? So now we have h of x. Let's go ahead and find h inverse. So how do we find h inverse? So h inverse, we swap x and y, right? We swap x and y and solve for y and solve for y. So let's go ahead and do that. So now we know that h of x is equals to 3 to the power x, right? So if we swap x and y, we shall get x is equals to 3 to the power y, right? So now we're just solving for y. But then how do we do that? Now we have to introduce log, right, on both sides. So we're going to say log of x is equals to log of 3 to the power y, right? So log of x will be equals to, if you introduce log, you can drop the exponent, right? So we're going to have y multiplied by log of 3. We are allowed to do that if we have log. And then from there on, we're dividing both sides by log of 3, right? The coefficient of y, so that we can get the inverse. So y is going to be equals to log of x divided by log of 3, right? So y is just going to be equals to log of base 3 to the x.
We have a function p of x which is equals to a to the power x, and then on our graph we have the point a, which is our y-intercept, and then some point t lying on the first quadrant, as you can see. And then the first question, 7.1, is saying let's find the coordinates of point a, right? So we've already established that point a is our y-intercept. So if point a is indeed our y-intercept, then it should have an x value of 0, right, and some value of y which we're supposed to find. So for us to find that value of y, we just have to substitute 0 into our equation p of x, right? So we can say that p of 0 will be equals to a to the power 0, but we know fully well that any number to the power 0 is 1, so we have p of 0 being equals to 1, right? So for the coordinates of a, we have an x value of 0 and a y value of 1, right? And just like that, we have the coordinates of point a. And then now moving to the second question, 7.2, it is saying that let's calculate the value of a, right, the variable in our equation. So we know that p of x is equals to a to the power x. Now we need that value of a. So what we can do here, we can substitute the coordinates of point t, which is 5 and 32, right, as we can clearly see. So the y value of p of x at point t, that is 32, and we're looking for a, and then to the power x, x is 5, right? So let's write 32 with the base of 2 and the power of 5. So we're going to have 2 to the power of 5 being equals to a to the power of 5, right? 2 to the power of 5 is just 32. So we can drop the exponents and equate the bases. So if we do that, we get 2 is equals to a. And then now we know that p of x is equals to 2 to the power x, right? And then we have determined the value of a. Now let's move to 7.3. So 7.3 is saying that let's write down the domain of p. So we know that p of x is equals to 2 to the power of x. So if you look at this equation here, you will realize that it is defined for all negative values of x, and it is also defined for all positive values of x. It's also defined at x is equals to 0, right? So we can say that the domain of our function p, we're running from minus infinity and then to positive infinity, right? It is defined for all values of x. Or you can write instead x is an element of real numbers, right? Yeah, but then we just want to see that you are aware that this function is defined for all values of x. And then 7.4 is saying that let's write down the equation of p inverse in the form y is equals to. So let's not forget, we know fully well that p of x is equals to 2 to the power of x. So if we want to find the inverse, we have to swap x and y, right, and then solve for y. So if we do that, in place of p of x, we put in x, we swap in x and y, right, then it's equals to 2 to the power y. And then from here on, we have y as our exponent, so we have to introduce log on both sides. If we do that, we're going to get log of x being equals to log of 2 to the power y. And then on the left hand side, we're going to have log of x still. And then on the right hand side, we can drop the exponent, which is y now, because we've introduced log, right? So we're going to have y multiplied by log of 2. It's easy to see now that we're just dividing both sides by log of 2. So if we do that, we're going to get y is equals to log of x divided by log of 2, right? And we can further simplify that into log of x base 2, right? And just like that, we have our inverse in the form of y is equals to, and then up to 7.5. So 7.5 is saying, let's determine the values of x if p inverse of x is less or equals to 5, right? So what is p inverse of x? It's what we just calculated in 7.4, right? So we have log of x base 2 being less or equals to 5. So let's go ahead and solve this. If we do that, we're going to get x being less or equals to 2 to the power of 5. So x is less or equals to 2 to the power of 5. We've already established above that this is equals to 32, right? And then just like that, we have the values of x for which p inverse of x is less or equals to 5, right? But then there's another restriction. We're talking about log of x base 2, right? And we cannot take log of a negative number or log of 0, right? So we have to also indicate that we need this x value to be greater than 0, right? Because if it is 0 or less than, then we have issues arising. So we need the value of x to be greater than 0.
Use the graph to determine the values of x for which f of x is greater or equals to minus 9. F of x is equals to minus square root of 27x. Let's go to the graph and look for values of x for which f of x is greater or equals to minus 9. You can see here at point P, the point we're given, that the y value is minus 9 and the corresponding value is 3. So 3 is one x value that we're interested in. But for which other values of x is f of x greater or equals to minus 9? Well, if you look at x is equals to 2, then our graph is greater than minus 9. And then if you look at x is equals to 1, our graph is still greater than minus 9. If you look at x is equals to 0, then our corresponding y value is equals to 0. So from x is equals to 0 to x is equals to 3, f of x is greater or equals to minus 9. So our answer will be an inequality. We need x to be between 0 and positive 3. And that is the answer to 6.1. Let's look at 6.2. Write down the equation of f inverse in the form y equals to. Indicate all restrictions. Right. So f of x, we know at this point that it is equals to minus the square root of 27x. To find the inverse, we need to swap x and y. So in place of y, we're gonna put x, and then in place of x, we're gonna put y. Now the only thing that we need to do is to make y the subject of the formula, and by doing so, we would have found the inverse. So what can we do here at this point? We can take a square root on both sides, right? So let's go ahead and do that. X squared, that is just x squared, and then on the other hand, minus squared, that will be positive, and then we're going to lose the square root here on square root of 27y. We're going to be left with 27. Let me not write that like that. We're going to be left with 27y, and if we divide both sides by 27, we're going to get y being equals to x squared divided by 27. So this is the inverse of f of x, but we are told that we need some restrictions, right? So what restrictions are we even talking about? What you have to know is that the range of the graph of your function, right, will be the domain of the inverse, will be the domain of the inverse, and then the domain of the original function will be the range of the inverse. That is how it works. If you look at the graph of f of x, you're going to realize that the range is y is less or equals to 0. So that tells us that the domain of our function will be x is less or equals to 0. That is a restriction we need to include them. Let's move to the following question, 6.3. Sketch the graph of f inverse in your answer book. Indicate all intercepts with the axis and coordinates of one other point on your sketch. 6.3, we have f inverse being equals to x squared divided by 27. This is the same as 1 divided by 27 multiplied by x squared, right? So we have a quadratic function. We need to indicate our intercepts. So x-intercept y is equals to 0. So if we let y be equals to 0, we're going to have x squared divided by 27. If you cross multiply, you're going to realize fairly quick that x is also equals to 0. And then the y-intercept will let x be equals to 0. So we're going to have y being equals to 0 divided by 27. Again, the y-intercept is at 0 and 0. So that is to say that our graph should look something like this, right? But then let's not forget that we have a restriction. Our restriction is that we are only interested on the values of x for which x is less or equals to 0. So we actually don't have this part on our function. We don't have this part because at that point x is now greater than 0. This is only the part we are interested in on our inverse. So this is our graph. What is left is for us to include one other point. So you just take a point and you substitute it on f inverse. You just substitute any point. If we substitute to minus 9, the answer we're going to get is going to be positive 3. So we have a point somewhere here of minus 9 and positive 3, right? We have a coordinate here of minus 9 and positive 3. And just like that, I think we are done with 6.3. Let's look at 6.4. Determine the transformation from f to g if g of x is equals to the square root of 27x. What is different between g of x and f of x? The only difference we have is that we no longer have the minus sign here. So what does that tell us? Well, it means that g of x is equals to minus f of x, because when you substitute f of x here, minus and minus are going to cancel out, and this is what we call a reflection about the x-axis. We have two functions, f of x, which is equals to 2x squared, and g of x, which is equals to a third to the power x, right? And then we have a point A on g of x, and the first question, 5.1, is saying let's determine the equation of f inverse of x, the inverse of f in the form y is equals to. So we've already established that f of x is equals to 2x squared. We need an inverse of this function, but then how do we possibly do that? We swap x and y and solve for y. So let me show you what I'm talking about. Instead of having f of x, I'm going to put x here, right? And then this is going to be equals to 2. Instead of x, I have y and then squared, right? Now I just have to solve for y. As soon as I'm done with that, I have the equation of f inverse in the form y is equals to. So let's go ahead and do that. It's easy to see now that I'm going to divide both sides by 2, and this will be equals to y squared, right? I divided both sides by 2. And then now what I'm going to do, I'm going to take square roots on both sides, right? So if I do that, let's take the square root of y squared and plus or minus the square root of x divided by 2. So I'm going to get plus or minus the square root of x divided by 2 being equals to y, right? And then we're supposed to have a restriction here because we know that we need x to be greater or equals to 0 for this equation to hold. And then just like that, we have answered 5.1, the equation of the inverse of f of x. And then moving to 5.2. So 5.2 is saying that for which values of x will minus 2 be less or equals to log of a third and then x, and still have that being less than 0, right? So let's go ahead and find our critical values. So let's go ahead and find our critical values. So we can say that log of x base, it's a third, right, is equals to minus 2. So let's go ahead and solve this. So we're going to have x being equals to a third to the power minus 2, and this is equals to 9, right? And then our other critical value, we're going to say that log of x base a third is equals to 0, right? So we're going to have x being equals to a third to the power 0. We know that any number to the power 0 is 1, right? So we have x is equals to 9 and x is equals to 1. So from here on, we have two possible answers, right? This is one of our possible answer. We're going to have x being greater than 9 or x being less than 1, right? That's one of our possible options. And then the second option, we're going to have x lying between 1 and 9, right? So we're going to have 1 here, and then x is supposed to be greater than 1 but less than 9. So 1 or 2 is our correct answer. The best way of doing it is substituting a value of x which is between 1 and 9, right? And if we get an answer which is between minus 2 and 0, then we know that that is the correct solution. And if that doesn't hold, then our first option will be our correct answer, right? So now we can say log of, so we have log of x. So let's pick 4, right, as a number which is between 1 and 9, and then our base is a third. And if you put that in your calculator, you should get minus 1.26. So you should get minus 1.26 if you put that in your calculator. So when we substitute a value which is between 1 and 9, we get an answer which is between minus 2 and 0. So this second option is our correct solution. And then now off to 5.3. So 5.3 is saying that let's simplify the following. So we have f of 1 divided by x plus 1 divided by f of x plus f inverse of x squared, right? So we have f of 1 divided by x, right? So we know that f of x is equals to 2x squared, right? So if you substitute 1 divided by x, we're gonna have 2, and then multiply by 1 divided by x squared plus 1 divided by f of x, that is just 2x squared, and then plus f inverse squared, right? We have calculated f inverse. We know that f inverse is square root of x divided by 2. We have a plus or minus here, right? And then we're supposed to square that. So if we compute that, we're gonna have 2 multiplied by, so we have 1 divided by x squared, right? So we're gonna have 2 divided by x squared, and then plus 1 divided by 2x squared, and then plus, so we square in square root of x divided by 2, so that will just be x divided by 2, right? So now we need to have the same denominators so that we can just simply add the numerators. So we can give this term here a denominator of 2x squared, and even this term here we can give it a denominator of 2x squared, right? So if we give the first term a denominator of 2x squared, it's just a matter of multiplying by 2, right? So we can say 2 multiplied by 2 divided by 2 multiplied by x squared, and just like that we have a denominator of 2x squared. And then the term in the middle, there's no issues whatsoever, so we just have 1 divided by 2x squared. Then the third term, to give it a denominator of 2x squared, we multiply everything by x squared, right? So we're gonna have x squared multiplied by x, and then divided by 2 multiplied by x squared, right? So now we have the same denominator, which is 2x squared, and then 2 multiplied by 2, that will be 4, plus 1 plus x squared multiplied by x, that will just be x to the 3, right? So this will be all equals to 5 plus x to the 3 divided by 2x squared. H of x is equals to a to the power x, right? And then we have a point P of coordinates minus 1.5 on our function h of x. And then the first question, 5.1, is saying let's write down the coordinates of q. So let's go to a graph and look at q, right? Q is situated here. It is our y-intercept, right? So if we're saying that q is a y-intercept, then we know that it has an x value of 0 and some y value which we can possibly determine, right? So what we can do here, we can say that h of 0 will be equals to a to the power 0, right? So any number to the power 0 is 1. So from this we can say that the coordinates of q, we have 0 for the x value and 1 for the y value. And just as easy as that, we have the coordinates of q. That's why the question actually says write down the coordinates of q. You don't even have to calculate it, you can just see it, right? And then now 5.2. So 5.2 is saying let's determine the value of a. We know that we have h of x being equals to a to the power x. So let's go ahead and substitute our coordinate p into h of x so that we can determine a, right? So if we substitute it into h of x, we're going to get a half for the y value being equals to a to the power minus 1. So we're going to end up with a half being equals to 1 divided by a. It's easy to see now that if these two things are equal, then a shall be equals to 2, right? You can just cross multiply, you will see immediately that a is equals to 2. Then for 5.3, the question is saying that let's write down the equation of h inverse in the form y is equals to. So at this point, we know that h of x is equals to 2 to the power x. Now we need to find an inverse. The first step in finding an inverse is to swap x and y, right? What am I saying? We know fully well that h of x is equals to 2 to the power x is the same as just y is equals to 2 to the power of x. Now we have to swap x and y. If we do that, we're going to get x is equals to 2 to the power y, right? And then if you solve this, then you have the equation of the inverse. But it looks a bit complicated now. We have y as an exponent. How do we go through that? We introduce log on both sides, right? So we're going to have log of x being equals to log of 2 to the power y. So log of x will be equals to, so we can bring y down because we've introduced the log, right? And then log of 2. Now we're just dividing both sides by log of 2, so we're going to end up having y being equals to log of x divided by log of 2. And this will all be equals to log of x base 2. And just like that, we have our inverse, right? Let's move to 5.4. So 5.4 is saying, let's sketch the graph of h inverse in your answer book. Clearly show all intercepts with the axis. So to sketch a graph, we don't need much, right? You need to know the general shape of the graph and the intercepts. But then we have y is equals to log of x base 2. For this graph we're going to sketch, we cannot have the y-intercept because log of 0 is not defined, right? We could only have the x-intercept. So let's go ahead and find the x-intercept, right? So x-intercept, we know that we need y to be equals to 0. So as a consequence, we're going to have 0 being equals to log of x base 2. So how do we solve this? We're going to get 2 to the power 0 being equals to x. And what did we say? Any number to the power 0 is 1, right? So this is where we have our x-intercept. The x value is 1 and the y value is 0, right? So now we can go ahead and sketch our graph. So somewhere here we're going to have our x-intercept. So there we go. We essentially done, right? We just need to sketch our graph. So it's supposed to look something like this, right? And then this is the y-axis and this is the x-axis. Let's move to 5.5. So 5.5 is saying that let's write down the domain of H inverse. So what's the domain again? The domain is the x values for which our function is defined, right? And our function here is only defined when x is greater than 0, right? When x is equals to 0, we have undefined. When x is negative, we have undefined. It's only defined when x is greater than 0, right? And then 5.6. 5.6 is saying that hence or otherwise determine the values of x for which log of x base 2 is greater than 1. You can use the graph to determine that, but then we're just going to do it algebraically, right? So we're going to have log of x base 2 being greater than 1. That's what we need, right? So if we solve this, we get x being greater than 2 to the power of 1. So x is greater than 2, right? So when x is greater than 2, log of x base 2 will be greater than 1, right? That's our answer for 5.6. 5.7. 5.7, they're saying that g of x is equals to 100 multiplied by 3 to the power x. And then calculate the value of x for which h of x is equals to g of x. So what is h of x again? H of x is 2 to the power of x. So we need some values of x for which 100 multiplied by 3 to the power of x is equals to 2 to the power of x. So let's isolate the 100 here. If we do that, we're going to get 100 being equals to 2 to the power x divided by 3 to the power x, right? But then we can write this nicely in the following way. So we can say 100 is equals to 2 divided by 3 to the power x, right? So in order to solve for x here, we can introduce log on both sides. So we can say that log of 100 is equals to, and then log of 2 divided by 3, everything to the power x, right? So what is log of 100? Log of 100 is 2, right? And then this is equals to. So now that we've introduced log, we can bring the exponent down, right? So we're going to have x and then log of 2 divided by 3. So you can see now that x is going to be equals to 2 divided by log of 2 divided by 3, right? And then x is going to be equals to minus 11.36 h of x, which is equals to log of x base a, right? And then we have a point P that lies on our function h of x. And then the first question, 7.1, is saying let's calculate the value of a. We've already established that we have a coordinate P of which the x value is a half and the y value is -1, right? So in order for us to calculate the value of a, we're going to substitute this point P on our function h of x. So let me show you what I'm talking about. So the y value, we're going to put -1, and this will be equals to log of x. Now we know that x is a half, right, at the point P, and then base a. So let's go ahead and solve this. If we do that, we're going to get a to the power -1 being equals to a half. But what is a to the -1? Is the same as 1 divided by a, right? And this is equals to 1 divided by 2. So it's easy to see here that a should be equals to 2, meaning that our function h of x, we can write it as log of x base 2 instead of a, right? And then now moving to 7.2. 7.2 is saying that let's write down the equation of h inverse, the inverse of h, in the form y is equals to. So as we have already established, h of x is equals to log of x base 2. So in order to find the inverse, you swap x and y, and solve for y. So let's go ahead and do that so that you can see what I'm talking about. Instead of having h of x, we're going to put x there. We swap in x and y, right? And then log of, instead of x, we're going to put y, and then base of 2. So if we solve for y here, we're going to have the equation of the inverse. So if we do that, we're going to get 2 to the power x being equals to y, right? So we have the equation of y. Y is equals to 2 to the power of x, and that is the inverse of h. Yes, it is that easy. And then 7.3 is saying that this is right on the domain of h inverse. So we say that h inverse is equals to 2 to the power x. The inverse of h is defined for all values of x. When we take x closer to negative infinity and we take x closer to positive infinity, there's no issues whatsoever. Even when x is equal to 0, there's no issues. So we know that the domain of h inverse is x, an element of real number, right? That function is defined for all possible values of x. And then 7.4 is saying let's determine the values of x for which h of x is less or equals to minus 1. Right, so what is h of x again? We know fully well that that is log of x base 2, and then it's supposed to be less or equals to minus 1, right? So let's go ahead and solve this. If we do that, we're gonna get x being less or equals to 2 to the minus 1. So x is less or equals to 2 to the minus 1 is the same as 1 divided by 2. That's our upper restriction. Now we need our lower restriction, right? We know that we cannot take log of 0 or log of a negative number, right? So we must indicate here that we need x to be greater than 0 but less or equals to a half. 5.1. So 5.1 is saying that let's determine the x-intercept of k, right? We're given the equation of k of x being equals to minus 2 divided by 3x plus 3, right? So in order to find the x-intercept, we let y be equals to 0, right? So if we do that, we're gonna get 0 is equals to minus 2 divided by 3 multiplied by x plus 3. So right now we're gonna take 3 to the left hand side. So we're gonna get minus 3 being equals to minus 2 divided by 3x. So we're gonna have x being equals to minus 3 divided by minus 2 divided by 3. So if you put that in your calculator, you should get x is equals to 9 divided by 2, or x is equals to 4.5, right? It is the same thing. So the coordinates for our x-intercept, we have 9 divided by 2 and 0 for the y coordinate, right? And then 5.2 is saying let's determine the domain of k inverse. So here we're given the equation of k of x and its domain, right? We're given the equation of k of x and its domain. So what is the relationship between k of x and the k inverse? So the domain of k of x is the range of k inverse, right? And then the range of k of x, as you would now expect, is equals to the domain of k inverse. This works for all functions and their inverses, right? Not just for this particular case. So here we're given the domain of k of x, but we're looking for the domain of k inverse. So let's use the domain of k of x to find the range of k of x, because we know that the range of k of x will be the domain of k inverse, right? So the domain of k of x, we have minus 4. And then it's supposed to be, we're supposed to have x between minus 4 and 6, right? So let's go ahead and find the range of k of x. So we're going to say that k of minus 4 being equals to minus 2 divided by 3 multiplied by minus 4, right? Plus 3. And this will be equals to 5.67. And then we have k, and then we substitute 6, we get minus 2 divided by 3 multiplied by 6 plus 3. And then if we put that in our calculators, we shall get minus 1. We can write the range of k of x in the following way. Let me write it down and then I'll do a bit of explaining. So we have minus 1, then 5.67, right? And then here we have a square bracket. Let me explain why here we have the bra and here we have the cat, right? Here we have the bra because 6, we're not supposed to charge 6, right? According to our domain. And then we're supposed to touch minus 4 according to our domain. So that's why here I put a bra and then here I have a cat. So this is the range for k of x. So the domain of x inverse, we would have x an element of real number, and then we just put the range like we have talked about, right? So that is the answer for 5.2. Right, let's move to 5.3. So 5.3 is saying that let's determine the equation of h inverse. So we have h of x being equals to 2 to the minus x, right? So in order to find the inverse, we have to swap x and y and solve for y. So let's go ahead and do that. If we do that, we're going to get x being equals to 2 to the minus y. So now we have y as an exponent. We introduce log to both sides so that we can bring it down, right? So we're going to have log of 2 to the minus y. So we have log of x being equals to minus y log of 2, right? So if we divide both sides by minus log of 2, we're going to get y is equals to log of x divided by minus log of 2. This will be equals to minus log of x base 2, right? And just like that, we have the equation of h inverse. And now moving to 5.4. So 5.4 says that let's give the coordinates of the x-intercept of h inverse. The coordinate of the x-intercept of h inverse. So again, x-intercept, we need y to be equals to 0, right? So if we substitute that in our equation, let's not forget that this is the equation of h inverse, right? So we're gonna have 0 being equals to minus log of x base 2. So we will divide both sides by minus 1 so that we can get this, we can get rid of this minus here, right? So if we do that, we're gonna get 0 because 0 divided by minus 1 will still just be 0 being equals to log of x base 2. So now this 2 will come and carry this 0. So we're gonna have 2 to the power 0 being equals to x, right? Any number to the power 0 is 1, so x is equals to 1, and then that coordinate we have 1 and 0, right? And then 5.5 is saying that for which values of x is k inverse less than 0. For k inverse, we now know what the domain is, right? And we also know what the range is because of the relationship we established between k of x and k inverse, right? The domain of k of x is the range of k inverse, and then the range of k of x is the domain of k inverse. But then how can we possibly find the x values for which k inverse is less than 0? Can you please let me know in the comments? Right, and then 5.6 is saying that if k of x, so we have k of x being equals to the derivative of q of x, where q is a function defined for minus 4 to 6, right? Draw a neat sketch of q, clearly show the x values of the turning points and the end points. So let's start with the x values of the turning points. We know that it's defined from minus 4 to 6, right? So, right, those are our ending points. Now we just need the x value of the turning point. How can you possibly find the x value of the turning point? We can say that k of x is equals to 0, right? Because k of x is the gradient of q of x. So if we equate k of x to 0, then we're going to find the x value of the turning point, because that's where the gradient is equals to 0. Right. So we're going to say that minus 2 divided by 3x plus 3 is equals to 0. So minus 2 divided by 3x is equals to minus 3. So x is equals to 9 divided by 2, or 4.5. Right. So now we have all we need to sketch your graph. So let's just go ahead, do that, and see what we have. Right. So there goes our y-axis, and there goes our x-axis. So let's see what we can do here. We know that our endpoints, we at minus 4 and positive 6, right? And then we have some point here, 4.5, and then that point is our turning point. So now let's look at k of x. K of x has a negative slope, right? So that tells us that our function q of x, which is a quadratic function, is supposed to be sloping down, right? So as a consequence, we're gonna have something like the following. So yeah, we're gonna have something like this. Yeah, so we're going to have something like this as a result, right? Yeah, my sketch is not too great.
We have two functions, g of x and the g inverse. We're supposed to find the y coordinate of b, the y-intercept of g of x. We are given the equation g of x being equals to 2x plus 6. If you want to find the y-intercept, you let x be equals to 0. So we're going to have g of 0 being equals to 2 multiplied by 0 plus 6. So y is going to be equals to 6. 2 multiplied by 0 is just 0. So that is the y coordinate of b. 5.1. Let's take a look at 5.2. Determine g inverse in the form g inverse is equals to mx plus n. We know that g of x is equals to 2x plus 6. In order to find the inverse, we need to swap x and y and solve for y. So in place of y, we're going to put x, and in place of x, we're going to put y plus 6. So 2y is equals to x minus 6. We just need to divide both sides by 2. So we're going to get y being equals to 1 divided by 2x minus 3. This is the equation of g inverse. Now we can conclude and say that g inverse of x is equals to a half x minus 3. Let's move to 5.3. In 5.3, we're supposed to find the coordinates of a. Let's go ahead and take a look at a. A is where g of x and g inverse touch. So in order to find the coordinates of a, we have to equate the two equations. If we do that, we're going to have 2x plus 6 being equals to a half x minus 3. Let me take a half x to the left hand side. If I do that, I'm going to get 3 divided by 2x being equals to minus 9. I'm taking plus 6 to the left hand side. I'm going to get minus 3 minus 6, which is minus 9. Now what I have to do is to divide both sides by 3 divided by 2. If I do that, I get x is equals to minus 6. So that is the x value at a. Now I just have to substitute x is equals to 6 into g of x, or g inverse. If I substitute it into g of x, I'm going to get 2 multiplied by minus 6 plus 6. So 2 multiplied by minus 6, that is minus 12. Minus 12 plus 6 is minus 6. So the coordinates of a is minus 6 and minus 6. That is 5.3. Quite easy to compute. Let's take a look at 5.4. In 5.4, we're looking for the length of AB. We have the coordinates of A and we have the coordinates of B. So finding the length of AB should be pretty much straightforward. We're going to have AB being equals to, we're going to use the distance formula. That is x2 minus x1 squared plus y2 minus y1 squared. This will be equals to, so the coordinates of B, we have 0 and 6. The coordinates of A, we have minus 6 and minus 6. If we take B as our second point, we're going to have 0 minus 6. So that is just 0 plus 6 squared. Plus y2. Y2, the y value of B is 6. So that will be 6 minus 6. So that is 6 plus 6 squared. So this will be 6 squared, 36. And then 12 squared, 144. 144 plus 36, 180. So AB is equals to square root of 180. Obviously, you can further simplify that and get 6 square root of 5. AB, let's do 5.5, the interesting question really. So in 5.5, we're supposed to calculate the area of triangle ABC. So let's just go ahead and highlight that triangle. There's quite a couple of ways we can use to find the area of triangle ABC. Let's just try this first. We can find the area of triangle DBC. Let me highlight it. We can find the area of this triangle. How can we possibly do that? We have the base DC and we have the height OB. We have the length of DC and we have the length of OB. And we can also find the area of triangle DAC, this area right here. We have the base DC again, but now we have this height of which we know the length, right? So we can go ahead and say that the area of triangle ABC is equals to the area of triangle BDC plus the area of triangle DCA. This is going to be equals to a half base. The base of triangle BCD is DC. What is the length of DC? The x-coordinate of C is 6 and the x-coordinate of D is minus 3. So from D to C is 9 units. So we're going to have that there. And then the height from O to B is 6 units. The y-coordinate of O is 0 and the y-coordinate of B is 6. So we're going to have 9 multiplied by 6 plus the area of triangle DCA. The base is DC. We know that DC is 9 units. And then now let's talk about this height. The y-coordinate A is minus 6 and the y-coordinate at the x-axis, it is 0. So that distance should also be equals to 6. This is equals to 54 units squared.
Is P an increasing or decreasing function? So that is 4.1.1, right? We have P of x, which is equals to 1 divided by 3 to the power x. So let's go ahead and find out whether this function is increasing or decreasing. How are we going to possibly do that? Let's start by substituting x is equals to 1 and see what we get. So if you substitute x is equals to 1 into P of x, you're going to get 1 divided by 3, right? And then if you substitute x is equals to 2, you're going to get P of 2 being equals to 1 divided by 9. And then if you substitute x is equals to 3, you're going to get P of 3 being equals to 1 divided by 27. Now it's actually easy to see that when the values of x are increasing, the values of y are decreasing, right? When x is equals to 1, we have 1 divided by 3. When x is equals to 2, we have 1 divided by 9. And then when x is equals to 3, we have 1 divided by 27. We can see from that test that our function is decreasing, right? Yeah, as the values of x increase, the values of y decrease. And then 4.1.2, determine P inverse, the inverse of P in the form y is equals to. So we have p of x being equals to 1 divided by 3 to the power of x. Instead of p of x, let's just put y in there. So we have y being equals to 1 divided by 3 to the power x. So when you want to find the inverse, the first thing you want to do is to swap x and y, right? So if we go ahead and do that, we're going to have x in place of y, right? And then in place of x, we now put y, right? And then from there on, all you just need to do is solve for y. Solve for y. As soon as you solve for y, then you're gonna have the function you're looking for. So how are we gonna possibly do that, right? Y is up here. We have to bring it down by introducing log on both sides, right? So we're gonna have log of x being equals to log of 1 divided by 3 to the y. Now you just have to recall that under log loss, log of a to the b is equals to b multiplied by log of a. So if we just apply that idea right here, we're gonna have log of x being equals to y log of 1 divided by 3. So we can go ahead and divide both sides by log of 1 divided by 3 in attempt to isolate y, right? And then if we do that, we're gonna end up having y is equals to log of x base 1 divided by 3, and that is the inverse of p of x. The following equation 4.1.3, let's write down the domain of p inverse. What I want you to know is that the domain of f inverse is equals to the range of f, right? So we're looking for the domain of p inverse. So actually we can find the domain of p inverse by just finding the range of p, right? And then for our function p of x is equals to 1 divided by 3 to the x. You can see that the range is going to be y is greater than 0. We are saying that to say that the domain of p inverse will be, so now we have the domain x is greater than 0, right? And then the last equation 4.1.4, write down the equation of the asymptote of p of x minus 5. So for any exponential function in the form a b to the x plus q, this q here will always be your asymptote, right? So let's go ahead and see what we're going to have for p of x minus 5. This will be equals to 1 divided by 3 to the power x minus 5. It's easy to see that in this function, our q is actually minus 5. So our asymptote is that y is equals to minus 5. We're given g of x, which is equals to 3 to the power x, right? And then the first equation 6.1.1 is saying that let's write down the equation of g inverse in the form y is equals to. So we want the inverse of g of x, right? How do you find the inverse of a function? So the first step, you swap x and y. So you swap x and y. And then the second step, you make y the subject of the formula, right? You make y the subject. Those are the only two steps you need to follow in order to find the inverse of a function. So let's go ahead and follow the first step. We're saying that we need to swap x and y, right? So initially we have y is equals to 3 to the power x. If we go ahead and swap x and y, we're gonna have x is equals to 3 to the power of y. So you literally put in x in place of y and put in y in place of x. We are done with the first step. The second step, you make y the subject of the formula, right? But then y is up here right now. So we have an issue. We need to bring it down by introducing log on both sides. So if we do that, we're going to have log of x being equals to log of 3 to the power y. If you introduce log, you can take down the exponent, right? So we're going to have log of x being equals to y log of 3, right? It's easy to see now what we are going to do. We're going to divide both sides by log of 3. If we do that, we're gonna therefore get y being equals to log of x divided by log of 3. We can write it nicely and say y is equals to log of x base 3, and that is the equation of G inverse in the form y is equals to. It's quite, easy and straightforward. And 6.1.2 is saying that point P of coordinates 6 and 11 lies on h of x. So we have h of x, which is equals to 3 to the x minus 4 plus 2, right? The graph of h is translated to form G. So we're translating h of x to form G. We know that G of x is equals to 3 to the power x, right? So now the question is saying, let's write down the coordinates of the image of P on G. So we need to translate P, right, the same way h of x is being translated to G. So let's call this P prime and see what we have. So let's start with this part here. On h of x, we have plus 2. But then on g of x, we don't have plus 2, right? So to move from h of x to g of x, you need to minus 2 from h of x, from the y values. So since we have 11 here, if we subtract 2, we're going to end up with 9, right? So we know that the y value we have here is actually 9, right? Now let's move to the x value. We have x minus 4. We started with x minus 4, right? And now we just have x. So what happened there? We said x plus 4, right? That's what we did. And then we know fully well that f of x plus k will move your x values to the left, right? So we're moving 4 units to the left. We started with 6. If we move 4 units to the left, we're going to end up at 2, right? We're going to end up at x is equals to 2. So we're going to have 2 here. And that is the coordinates of the image of P on G. 6.1.2. Let's move to the following question, 6.2. So we have 6.2, and the question is saying that let's sketched is the graph of f of x. So we have some function f of x, which is equals to 2 to the x plus p plus q. And then we have a coordinate t of coordinates 3 and 16 on f, and the asymptote of f is y is equals to 16. Yeah, we can clearly see the asymptote on the graph we're given, right? And then now the question is saying, let's determine the values of p and q. Let's determine the values of p and q. So how can we possibly do that? We're going to start by looking at the value of q, right? So we are interested in the value of q. So q is equals to minus 16. Let me explain why I'm claiming that, or why I'm saying that q is equals to minus 16. That is because for any value of x, we can substitute here. For any value of x, we can substitute here. F of x will never be less than minus 16, right? You can see it from your function here, that for any value of x you substitute, f of x will never be less than minus 16, right? That's as low as it can go. So now we know fully well that f of x is equals to 2 to the x plus p minus 16. For whatever value you can substitute here, f of x will never be less than minus 16. That is why we're saying that q is equal to minus 16, right? Right, and now we just need to find the value of p, of which we're going to substitute our coordinate t. So we're gonna sub in t of 3 and 16. So if we do that, this is the x value, this is the y. We're gonna get 16 being equals to 2 to the 3 plus p minus 16, right? So I'm gonna take minus 16 to the left hand side, and I will get 32 being equals to 2 to the power 3 plus p. I wish it was possible for me to write 32 with the base of q, so that I can drop the bases and equate the exponents. I actually can't do that because 32 is just 2 to the power of 5, and then that will be equals to 2 to the 3 plus p. So now you can see here that I'm going to say 5 is equals to 3 plus p, right? And then 2 is equals to p. That becomes easy to see now. Given that f of x is equals to 4 divided by x minus 1 plus 2, write down the equations of the asymptotes of f. That is 4.2.1. So you can see just from how the function looks that we have a hyperbola, right? One of the asymptotes will be at y is equals to 2. This value here, right? So we're gonna have our horizontal asymptote. So we have our horizontal asymptote being at y is equals to 2. Now what we need is our vertical asymptote. Our vertical asymptote will be at this denominator equals to 0, right? Because we know that we cannot divide by 0. So if you equate the denominator to 0, you're gonna find an x value for which the graph never touches, right? So if we go ahead and do that, we're gonna have x minus 1 is equals to 0, and then x is simply equals to 1, right? That is easy to see. So we have our horizontal asymptote and we have our vertical asymptote. That is 4.2.1, right? The value that is in here, this value right here, will always be your horizontal asymptote. If it was minus 3, then our horizontal asymptote would be minus 3, right? That's how it works. And then now moving to 4.2.2, the question is saying that let's calculate the x-intercept of f. We're looking for the x-intercept of f. As soon as I hear x-intercept, so we have x-intercept, I'm thinking y is equals to 0, right? So if we let y be equals to 0 in our function, we're going to have 0 being equals to 4 divided by x minus 1 plus 2. What we want to do when we have something like this is to subtract 2 from both sides, right? To get minus 2 is equals to 4 divided by x minus 1. And then if we cross multiply, we're going to get minus 2x plus 2 is equals to 4. Minus 2x will be equals to 2, and then x will be equals to minus 1. So the coordinate for our x-intercept, right, we have minus 1 and 0, right? And then now 4.2.3, we are required to sketch the graph of f and label all asymptotes and indicate the intercepts with the axis. So in 4.2.2, we only calculated the x-intercept, but then now we are required to indicate their intercepts, right? So we need to find the y-intercept. So y-intercept x is equals to 0. So let's go ahead and find the y-intercept so that we can be able to sketch our graph and indicate all that we are required to, right? So we're going to have y being equals to 4 divided by, now x is 0, right? Minus 1 plus 2. So we're going to have 4 divided by minus 1 plus 2. This is minus 4 plus 2. This is equals to minus 2, right? So the coordinate for our y-intercept, we have x being equals to 0 and y being minus 2. Right, so now we have the asymptotes, we have the intercepts, we can sketch our graph. Let's go ahead and do that. So we need our axis, obviously, right? We cannot have it any other way. So there goes our y-axis and there goes our x-axis. So the first thing we want to do is to put our asymptotes first, right? So let's just say this is 1, 2, 3. And then this can be minus 1, minus 2, minus 3. And then again for the y-axis, 1, 2, 3, minus 1, minus 2, and minus 3. So right, so let's go ahead and put our asymptotes in our graph, right? We have a horizontal asymptote at y is equals to 2. So let's just go ahead and have that there. So there goes our horizontal asymptote. And then our vertical asymptote is at x is equals to 1, right? So let's do likewise. There goes our vertical asymptote. Right, now we just need to indicate the intercepts. We have one intercept at minus 1 and 0, right? The x-intercept. So we're going to have a coordinate right here at minus 1 and 0. And then the other one is at 0 and minus 2. So we have another intercept here. And just like that, we're almost done. We just need to sketch our function, right? If we go ahead and do that, we should have something like this. So our graph should go through our intercepts, obviously, right? And then, yeah, that is one part of our function. And the other part of our function will lie in the first quadrant, right? Right, there we go. We're supposed to have something like that. We've indicated our asymptotes, we've indicated our intercepts. I think we're good to go, right? Let's do 2.4. So 2.4, using the using our graph, let's determine the values of x for which 4 divided by x minus 1 is greater or equals to minus 2, right? If we take minus 2 to the other side, we're going to have 4 divided by x minus 1 plus 2 is greater or equals to 0, right? So what we're actually looking for here, we're looking for the values of x for which our function f of x is greater or equals to 0, right? Because this is simply f of x if you look at it. Right, so let's go to our function and look for the values of x for which our function is greater than or equals to 0, right? We can see that for this entire part of the function, it is greater than 0, right? And then here from minus 1, if we go to that side, our function will be greater than 0, right? So part of our solution, we have x being greater than 1, right? When x is greater than 1, our function is clearly greater than 0, right? And then when x is less or equals to minus 1, our function is also greater than, yeah, it's greater than 0. It's greater than 0. It's greater or equals to. So here we can put in this equals to, right? It's not going to cause us any issues because our function is defined at x is equals to minus 1. But then here we cannot have an equals to because our function is not defined when x is equals to 1, right? So we're supposed to say x greater than 1, right? And then the last question, 4.2.5. let's determine the equation of the axis of symmetry of f of x minus 2 that has a negative gradient. So what is this f of x minus 2? Let's figure it out. So we know that f of x is equals to 4 divided by x minus 1 plus 2. So f of x minus 2. So in place of x, we now gonna have x minus 2 and then minus 1 plus 2. Right, and then this will be equals to 4 divided by x minus 3 plus 2. Right, so this is what they're talking about when they say f of x minus 2. So we need the equation of the axis of symmetry that has a negative gradient. So we have two axes of symmetry, one with a negative gradient and then one with a positive gradient. So the one with a negative gradient, y is equals to minus x plus c, negative gradient. And then the one with the positive gradient, we have y is equals to x plus c. So what you're required to do actually is to just find the value of c, right? And then you have your axis of symmetry. So which point did you substitute if you want to find the value of c in your axis of symmetry? You substitute the point where your asymptote starts. So now we actually have to find the asymptote of f of x minus 2. Let's go ahead and do that. We know that 2 will be our horizontal asymptote. Now we just need to find our vertical asymptote by saying that x minus 3 is equals to 0. Right? Now you're gonna see that x is equals to 3 is our vertical asymptote. So they're gonna touch when x is equals to 3 and y is equals to 2. Now we just need to substitute that in our equation for the axis of symmetry with the negative gradient. Right? So if we go ahead and do that, y is 2, right? And then minus x is 3 plus c, right? So if we take minus 3 to the other side, the way you would say it, we would have 5 is equals to c, right? And then now we have y is equals to minus x plus 5 being the equation of our axis of symmetry of f of x minus 2.
Determine the values of p and q if the asymptotes intersect at x is equals to 1 and y is equals to minus 3. So we are given the equation of f of x. It is said to be equals to a divided by x plus p plus q. In order to find the value of p, we let x plus p be equals to 0. But we already have the value of x. It is equals to 1 at the vertical asymptote. So 1 plus p is equals to 0. It is now easy to see that p is equals to minus 1. The value of q, on the other hand, is just equals to the horizontal asymptote, which is minus 3. P is equals to minus 1 and q is equals to minus 3. So f of x, now at this point, we know that it is equals to a divided by x minus 1 minus 3. In 4.1.2, we are looking for the value of a. How are we going to possibly find that? We're going to substitute the y-intercept or any other point on the graph. So the y-intercept, x is 0 and y is minus 5. So let's go ahead and substitute that in our graph. We're going to get minus 5 being equals to a divided by 0 minus 1 minus 3. If we take minus 3 to the left hand side, we're going to get minus 2 being equals to a divided by minus 1. It should be easy to see now that a is equals to 2. So that is 4.1.2. Let's go ahead and do 4.1.3. If f of x is translated to g of x, describe the translation from g to x. So let's go ahead and take a look at this. In f of x, we have x minus 1. In g of x, we have x minus 3. So when it comes to the x values, x minus shifts the graph to the right and x plus shifts the graph to the left. We had x minus 1 On g of x, we have x minus 1 minus 2, which is just x minus 3. So we have moved 2 units to the right. We can go ahead and write it down as moving 2 units to the right. On f of x, we have minus 3. On g of x, we have plus 3. From minus 3 to plus 3, you need to add 6. So we have shifted our graph 6 units up. So here we're going to have 6 units up. 4.1.4, write down the equation of the horizontal asymptote of g. The horizontal asymptote is this value here all the time. So for 4.1.4, we can easily say that y is equals to 3.
Is equals to 1 minus 1 divided by x minus 2. Right. And then at A, we have a y-intercept, and then at the point B, we have our x-intercept of h, right? And then 5.1 is saying that let's write down the equations of the asymptotes of h, right? So we have the vertical and the horizontal asymptote. Let's start with the vertical. So vertical asymptote, right? Let's put our attention to the vertical asymptote. So the vertical asymptote, it comes from this part of the equation, right? Let me show you how. We know fully well that we cannot divide by 0, right? So if we say x minus 2 is equals to 0, then we will find a vertical asymptote. The x value, the graph is never allowed to touch, because if it touches that point, then we divide it by 0, and that is not allowed, right? So if we solve this, we're gonna get x is equals to 2. And just like that, we have our vertical asymptote, right? Our vertical asymptote is that x is equals to 2. So this point here, we have 2. The x value is 2 at that point. And then now that we have the vertical asymptote figured out, we just need the horizontal asymptote. So let's go ahead and find the horizontal asymptote. Now I want to show you something. H of x, right, it can never be equals to 1. Why am I saying h of x can never be equals to 1? Because for h of x to be equals to 1, we would need this part here of the equation. We would need this part of the equation to be equals to 0 for h of x to be equals to 1. And we know fully well that that can never happen. So our horizontal asymptote will be y is equals to 1. And then the next question, 5.2. So let's do 5.2. 5.2 is saying that let's calculate the coordinates of A and B. So let's start with A, right? Let's start with A. A is our y-intercept, right? X is equals to 0, right? So if we substitute that into h of x, so h of 0 will be equals to 1 minus 1 divided by 0 minus 2, right? So we just have 1 plus a half. And then what is 1 plus a half? That's 1.5, right? Or 3 divided by 2. So the coordinates of A, we have 0 as the x value and 3 divided by 2 as the y value, right? And then the coordinates of B, let's move to the coordinates of B. So B is the x-intercept. We know that y is equals to 0. So if we substitute that into h of x, we're going to get 0 is equals to 1 minus 1 divided by x minus 2, right? Minus 1 will be equals to minus 1 divided by x minus 2. So we can simply cross multiply here. If we do that, we're going to get minus x plus 2 is equals to minus 1. So we're going to have minus x being equals to minus 3. So x is equals to 3, right? So we have our coordinate B of coordinates 3 for the x value and 0 for the y value. Just like that, we have A and B. We can move to 5.3, right? So let's move to 5.3. So 5.3 says that let's write down the equation of the line of symmetry of H with a positive gradient. So the line of symmetry with a positive gradient will be y is equals to x plus k, where k is a constant, right? So what we need to do here is to basically find the value of k. But then we don't just substitute any point on the graph. We don't even substitute a point on the graph. We substitute the asymptotes. We know that we have x is equals to 2 and y is equals to 1 as our asymptotes, right? This is what we substitute when we want to find the equation of the line of symmetry. So if we substitute this, we're going to get 1 being equals to 2 plus k, right? And then it is easy to see now that minus 1 will be equals to k, giving us an equation in the form y is equals to x minus 1. So this is the equation of the line of symmetry with a positive gradient, right? It's pretty much straightforward. And then 5.4 is saying, let's write down the range of h. Y is an element of real numbers, but y is not equals to 1. Because in 5.1, when we were talking about the horizontal asymptote, we say that y should never be equals to 1, right? Everywhere else our graph touches